Thank you very much for that very generous introduction and also for this opportunity to speak to such a large community. I look forward to meeting maybe several of you on various occasions if you haven't met already. I would like to introduce you to my book, which was published a couple of years ago. And This book is specifically designed to help users in the field of history, archaeology, and heritage conservation to use satellite imagery and GIS for the purpose of cultural heritage. So I begin and I look forward to discussion later. So, with or without our consent, details from our daily lives are being captured and stored in vast digital databases. If humanity were to vanish tomorrow and alien historians chanced upon these databases centuries hence, they would have incredibly rich resources for studying humanity's past. As humans in 21st century, trying to understand our own past, we have no comparable detailed databases to tap into. Instead, we must scavenge for traces of past human activity that have survived in material form and develop expertise in interrogating these material before their secrets fade into oblivion. To scrutinize written records, we turn to historians. We rely on archaeologists to scrutinize ancient materials ranging from small-scale fragments of pottery, jewelry, bones, and bricks to large-scale artifacts such as individual buildings and whole settlements. In each of these domains, scholars have benefited from the scientific developments that are constantly expanding the kind of ancient materials that are interrogable and the technological advances that enhance our ability to extract useful information from them. Remote sensing contributes to a branch of archaeology that scrutinizes landscapes, such as this, for instance, at Nalanda. Humans necessarily scar the landscape when they construct structures like forts, canals, tanks, and road networks. These scars, which can survive for many centuries, are also material records of the past human activity and are therefore worthy of study. However, these scars are difficult to discern at ground level, and their value was largely unrecognized until they were observed from an aerial perspective, initially from aircrafts and more recently from satellites. Lieutenant Colonel G.A. Beasley, a sapper of the Royal Engineers in Mesopotamia during the First World War, spotted distinct outlines of ancient canals in the course of his repeated flights over the then enemy territory, Tigris and Euphrates Plain. While carrying out a survey of contested area beyond Baghdad, he wrote, "The remains of an ancient city was disclosed which would not otherwise have been discovered in all probability. It was the old Samarra." As you can see in this image, the layout of old Samarra in the center of the figure is very distinct from the layout of the rest of the modern settlement, which was visible to this pilot. A more recent example here is the false color image of Bangalore. And here is a map of Bangalore made in 1791, which shows a four-cornered settlement and an oval-shaped citadel on the south. If you carefully analyze the satellite image, we can identify where exactly was the old settlement. We can still see the pattern of the old settlement. Apart from such images, analysts can pull together spatial data from other sources, including old maps, paintings, textual reports, and field surveys. Here is an example of Kollam in Kerala. Here is a map made in 1630 by Portuguese of Kollam. Here is another map made by Portuguese in 1635. Here is a map made by Dutch in 1687. You would wonder whether the Dutch map is of the same location of the other maps at all. Here is a painting made of the bay in Kollam in 1760 to 80. Now, using the old maps, which is an oblique view, old Portuguese map, and the painting, we are able to identify which is the building that we can see in the painting. Now, using ground truth, that is what is left from on ground, which is also remains of a three-storied building, we can identify that what is left on ground is the only three-storied building in that settlement. Analyzing these two maps with satellite imagery, we can, these three maps with satellite imagery, we can actually identify what was the Dutch extent versus what was the Portuguese extent, what versus what is left now as remains in Kollam. This coherent spatial view allows an analyst to hunt for visual patterns in a landscape in a manner akin to an art historian examining a painting through an appropriate historical lens. Furthermore, just as a modern art historian uses technology to scrutinize what lies beneath the topmost layer of paint, advances in technology of remote sensing permit satellites to view landscapes in different wavelengths and reveal hidden layers of human artifacts. I'm sure you would have already had lectures on lidar, for instance, and aerial lidar in that way can actually reveal what lies underneath vegetation. The purpose of such analysis is to identify, understand, conserve, and protect remnants of our past. This field, therefore, brings together knowledge from archaeology, history, art history, architectural history, heritage science, geoarchaeology, geomorphology, remote sensing, geographic information system, and cultural heritage conservation and management. Although I'm not an expert in all these domains, my research group has brought elements from each of these domains in investigating landscapes surrounding several archaeological sites, and we have had the immense satisfaction of contributing to our overall understanding of these sites. While all these sites are situated in Indian subcontinent, my research has helped me recognize and articulate several principles that I'm excited to present today. Here, marked in red, are sites that we have worked in one way or the other, maybe not all in the same extent as the other, but just to show how in the Indian subcontinent, the surface geomorphology is very different from, say, coastal area to the Deccan Plateau to the Gangetic Plains to the desert and so on. So we have tried to cover as many as the varied geomorphology as possible so that we understand this technology and how it works in different landscapes. I will discuss a few ideas which I articulate in this book. The first one, or the chapter one, is landscape archaeology, role of remote sensing and GIS. The primary focus here is on built heritage that have made marks on the Earth's surface in the process of being built or modified. These structures contribute the known remnants of built heritage at the site, and it is possible that hitherto unknown remnants associated with the site still exist in its vicinity. Consider the vicinity of Nalanda, for instance. When we visit the site protected by Archaeological Survey of India, we see these sacred temple structures called chaityas. There are 6 of them, and there are 10 dwelling structures or monasteries which are called vihara. Each has a central hall and surrounded by monastic cells. This infrared image shows the protected site of Nalanda and the area immediately around it. Notice how 4 temples in the protected region lie at regular intervals. The temples are marked in blue. Lie on regular intervals along a straight north-south line. If Nalanda had more temples, one might expect them to lie further along this line. Sure enough, The infrared image suggests the of one unexplored mound to the south and one to the north. In the north, one can also see two crop marks at exactly the intervals we are expecting. The central thesis of my presentation is that careful study of the site's vicinity or spatial context can lead to two important types of discoveries that may improve our overall understanding of the site and inform our strategies for its protection. Firstly, the discovery of further instances or attributes of built heritage. And secondly, the discovery of artifacts such as former water bodies, canals, activity at the site. The next chapter, landscape morphology and spatial patterning of archaeological signatures when viewed from above. This chapter discusses what kind of patterns, what do you see from when you see satellite imagery? You might think that somebody who knows to analyze will be able to see more than a person who's looking at satellite imagery for the first time. So what do we need to know to be able to identify such features? By viewing a landscape from a vantage point of aerial or space platform, one is able to observe how landscapes evolve over time and also get a sense of the implication of this evolution for the analyst seeking to identify archaeological features from above. For instance, the well-known example of a crop pattern in the fields, first observed in aerial photographs of World War I and II. Here is an example, not of during World War, but later, but a similar kind of crop pattern. As you can see, there is a circular pattern in the field. These turned out to be surface impressions of buried fort wall and adjacent moat. So here is a diagram showing a fort wall and and a moat, and would have existed at the time it was spread for the top of the building material gets removed for reuse, and only foundations get left. And similar agriculture is practiced on top. So these form positive and negative crop mark. And if that particular fort or a moat was in circular shape, you would see patterns like the one seen in this aerial image. But this is only one of different ways a landscape can morph itself, which depends on what has been happening subsequently on the surface. Even in urban jungle like cities, one can see traces of past layout which are inscribed as road or land use pattern. A ruined, disused wall become hindrance in mobility, and people and goods move along it, creating paths, which over time become roads and remain as permanent scar even if land use on either side keep changing. Like these diagrams show. For instance, take an example of Old Delhi. Jama Masjid and Red Fort, Lal Killa, are easy to find on a Google Earth image because they are still active. Lal Killa was the citadel of a much larger fort encircling Shahjahanabad, which no longer exists. We still see a satellite image with this 19th century map of Delhi, which shows the surrounding fort wall of Shahjahanabad. Now I hide this map, and suddenly you see where the fort lay, because the location of the fort is marked by the major roads that are going around it. This is an example of how a site looks in an urban area. Similarly, the manifestation of sites in different kinds of land surfaces vary accordingly. When I was writing my book 2 years ago, I wanted a term to refer to the landscape in the vicinity of a site that included the area that affects the site as well as area affected by the site. Since none of the existing terms seemed suitable, I called it spatial context. For a given site, we would like to identify features in satellite images of its spatial context that may provide new archaeological insights for that site. When we look at a site's spatial context today, we see only the present point in its evolutionary trajectory. For some sites, we may have historical spatial records that provide multiple snapshots of this spatial context as they change over time. These records may date from few years ago, that is from satellite imageries, either from Google Earth or Bhuvan or other portals, or a few decades ago. Example, Corona satellite imageries and other older satellite imagery, or a few centuries ago. For example, old maps, paintings, spatial descriptions in historical texts, like I showed, for instance, example of in Kolar. Even with multiple snapshots for a site, our data is generally too sparse to precisely infer the sequence of gradual changes to its spatial context. This lack of data forces us to guess how the spatial context evolved and to use these guesses to explain why we can or cannot observe certain features. Images may directly show certain surface features, while some subsurface features may only be visible indirectly through certain morphological expressions. For example, here is a 19th century map of Lalkot and Kila Rai Pitora in Delhi, which shows the spatial layout and shapes of the fort walls. Then, an image of 1965, which shows quite a bit of the fort walls. And then a recent image where most of the land use over and along and around the fort wall have changed. In most cases, recent image is what we have. And we have to hypothesize the reverse order, which is sometimes aided by old images, maps, records. Thus, understanding the landscape morphology and spatial patterns of sites provides the basis for answering critical questions such as what features should I be looking for in satellite images? And why can't I see what I'm looking for in a particular image? The next chapter is titled The Science and Technology of Remote Sensing in the Context of Archaeology. There are various types of imaging technologies. I'm sure you would have been introduced to several of them in the last few days, in the last week, in other lectures. So there are various technologies that are operational on contemporary and retired Earth observation satellites. Understanding these help the analyst answer the question, is this type of image likely to be useful for my analysis? For instance, look at these images of landscape of Belur in Karnataka. The one on the left is a false color image with infrared band. It shows the circular moat. You can see a red circle here. It shows the circular moat that surrounded the old settlement. Whereas the natural color image on the right, though of higher resolution, doesn't show the circular pattern clear. Once you have seen in the left image, you might be able to make out, but it doesn't stand out as a circle as it does in the left side image. Understanding the science behind these technologies help us answer the inevitable question, follow-up question, why and why not? So this chapter discusses why, for instance, an infrared image shows more brighter contrast in vegetation than in other technology. Here is an example of a leaf structure. When the sun's light of various bands fall, the surface the red and the blue colors interact with the surface and is largely reflected. That's why we see vegetation in green. Whereas the infrared penetrate towards of the leaf and then are diffused. And therefore, we get higher reflectance in infrared compared to others. And this is what we try to cache in and see if we are able to see better contrast with infrared imagery. The next chapter is GIS, an array of tools for archaeology. GIS is an associated technology that is used for analyzing remote sensing images. Images by itself is like a photograph, but bringing images into GIS platform fixes the image to its geo coordinates, doing which enables overlaying multiple spatial layers like maps, field records, making and therefore making measurements and analytics and extracting information from them becomes easy. Here is just an example of how an old map has been georeferenced on a satellite image for it to match. So that once we match one layer to analyze the changes that has happened between these layers. The next chapter is case studies, where I discuss 5 case studies in this chapter. Here I briefly illustrate 5 case studies to demonstrate that there is no fixed answer to the question, how should I conduct geospatial analysis for sites of interest? This is to re-emphasize the core ideas in the themes discussed earlier in more complex settings. In our experience, there is no fixed or formulaic approach to geospatial analysis of archaeological sites because the process of analysis is sensitive to variation between sites. These variations can be grouped into 5 principal categories. So in our experience, sites can be different in 5 different ways. For instance, first variation in features of interest. Like these will vary across sites in terms of their scale, their architectural styles, and so on. So by features of interest, I mean, if you are looking at a Mughal site, you'll be looking for features in the shapes of Mughal architecture. If you're looking at a Buddhist site, you'll be looking for features that are typical of Buddhist architecture. Similarly, Harappan sites maybe, and many others. So the sites vary in terms of features of interest. Second, variation in natural setting and subsequent natural changes. So the sites can be in plains, like Gangetic plains. They can be in Deccan Plateau or in the desert or in arid land and so on. So they can vary in their location, in their natural location and subsequent natural changes. Sites can be affected, say, by flooding or weathering or heat or cold and so on. So sites can vary in their natural setting and subsequent natural changes. So therefore, the setting and the subsequent natural changes has its implications on how a site is visible on satellite imagery of today. Third one, anthropogenic changes. Site will vary in terms of subsequent human activities and their impacts. Like we saw in the case of Delhi, for instance, where large cities have grown over the sites, or sometimes large amount of agriculture has happened over the sites. So anthropogenic activities and its impacts can also vary and therefore has implications on how a site becomes visible on satellite image. Fourth one is satellite imagery, availability of satellite imagery. Data from satellites may be plentiful in some sites but limited in others. So satellite imagery is not so variable, but maybe images like availability of LIDAR data or old satellite data or radar data and so on can vary. Or maybe availability of data of a particular season can vary. The fifth is historical spatial records. That is, the quality and quantity of such records may similarly vary of some sites. You may find some sites are studied extensively and has lots of archaeological reports, many surveys done in the last 150 years, whereas some sites maybe not much data at all. So depending on what is already known about the site, so tackling that site also becomes similarly uh, challenging. The purpose of this discussion is to illustrate how the process of analysis responds to these variations. Thus, we have carefully chosen 5 sites in this book so that there are significant variation across these sites in each of these 5 categories. The 5 sites are, the first one is Nalanda, which I have already spoken about in some, I have already referred to in the other chapters. So, where I also indicated how there are other, this is the protected area, and there are other mounds which are aligned with the protected area on the north and south. So, here is a map showing how the protected area is and in how much area we are able to find remains of archaeological interest. Also, it shows a cluster of water body around this site, which also indicate the expanse of archaeological landscape in this region, because all these water bodies are also either square or rectangle, and they are addressing cardinal directions. So they were also laid out with a purpose. They are not simply there by chance, but they were laid out with um, careful alignment. We also found a paleo channel that drew water from the nearby river Panchana towards this one water body that is extending eastward. As you can see, all the water bodies around Nalanda are tightly hugging this ridge on which the Nalanda sits, whereas one water body is sort of stretching eastward. This also indicates that this water body was laid out like this in order to be able to access water from this paleo channel, bring it, and probably further spill over to other water bodies in this region. So in that way, our work on Nalanda site has identified a much larger landscape of archaeological features in the vicinity of the protected site of Nalanda. The protected site itself is about 1 kilometer north to south and 1 kilometer east-west. And the area identified to have the remains of the old Nalanda stretches about 5 kilometers north to south and 2 kilometers east and west. The next site I want to discuss briefly is Agra. Uh, I'll go back to Nalanda for a minute. Nalanda is in the Gangetic Plains. It is south of Patna, the southern Bihar, and is known to have been active between 4th, 5th century to the 12th, 13th centuries. And it has structures that are mainly Gupta and Pala period. Now I come to Agra, which we all know is a Mughal period settlement, and a settlement that Babur had come first and later became more prominent when Akbar was the king and had a settlement, large settlement during Shah Jahan's time and later too. My work on Agra has concentrated on using this map, which was made in India for the use of Savai Jai Singh, who was the governor of Agra. And this map has a layout of Shahjahani Agra. It had, as you can see, the river bend, your river Yamuna bends, and it shows Taj Mahal here and Agra Fort here. And it shows about 50 riverfront gardens on either side. So these were all Mughal gardens with Havelis on either side. We don't have so many of them. Even Taj Mahal was one of them. Agra Fort was the other, and there were about 50 riverfront gardens, and they formed the core of the settlement. Then there was one tier of wall, enclosure wall with ditch surrounding it, and the ditches also went out of the settlement, or rather, the ditches brought drainage into the settlement and drained it into the river. There is a second tier of wall further along, which encompasses this whole area. So my curiosity was that if we have a map like this which directs us about how the site was laid out, whether we can use satellite imagery and try and identify all these features. So we did quite a detailed analysis and we found almost all of these 50 riverfront gardens that dot on either sides of this bend of River Yamuna. So I have marked in yellow the gardens that are protected. For instance, this is the Taj Mahal layout of Taj Mahal, and the opposite side is Mehtab Bagh. This is the Agra Fort. This is Itmaduddaular's tomb. This is Ram Bagh, and this is Chini Ka Roza. These are the protected uh, uh, baghs of Agra. The remaining in between, the ones on the west of the river, have succumbed to urbanization. However, you can actually identify these patterns in the layout. You will find that the blocks of construction has happened keeping these layouts as roads. So we were able to identify actually the extent of each of these sites, Havelis, and we were able to identify the inner tier of the wall because of this network of ditches, which quite a lot of it is still active. And the outer tier we were able to identify because of comparing it with archaeological reports of somebody who surveyed, Carlisle, who surveyed this area in 1873. So using multiple sources of data such as records, old maps, and satellite imagery, we could actually place every location that we know from this map. Another point I want to just refer to in this old map, as you can see, the map is not spatially accurate. It is somewhat compressed east-west and elongated north-south. These were not made with the modern trigonometrical survey techniques, which makes planimetric map, but this was an earlier technique used in local area. So this is Agra. The next site I will discuss is a famous name in Bangalore. There is a Lal Bagh in Bangalore, which is now a botanical garden. It was originally a series of baghs laid out by Tipu Sultan and his father Hyder Ali. But the fact that there was a Lal Bagh in Srirangpatna had been forgotten in local memory. Then we found this map, part of which we have put on the corner. And this map actually mentions Lal Bagh Palace. And it also shows a kind of palace in the center and radial roads on 3 of its sides. So what we did is to take high resolution satellite imagery, and we tried to identify that place, which is marked as 17 here. And there is some feature in the center. And we also tried to identify how the field boundaries are laid out surrounding it. And we found a neat charba kind of a layout with radial paths. We went to the site and we also found a lot of ruins in the center. And very interestingly, we found in these 2 locations, 2 Kabutar Khana, or the dove cotes. One had fallen and the other was erect, which are now standing amidst agricultural fields. But then we also found a painting which is titled Entrance of Lal Bagh Palace of Srirangpatna. And this is the entrance, and it had 2 dove cotes on either side. Though the entrance doesn't exist, the dove cotes are still lying on the fields there. So again, here is another example of, this is not very old. It is 18th century. But as you can see on the surface, it's almost gone. The buildings are in ruins. In this case, it's not entirely natural degradation. This particular building was specifically brought down because of political reasons following Tipu Sultan's death. But nevertheless, using old maps, ground truth, satellite image, paintings, we can actually identify their location and extent. The next site I want to briefly discuss Talakadu is a site I originally worked first during my PhD work. Again, Talakadu is a site which was active in the 5th century till about 16th, 17th, 18th century. Different dynasties took over. And it lies in the hairpin bend of River Kaveri. And this hairpin bend has lot of sand accumulation, which has caused the whole settlement to be buried. And in British time, British actually planted lots of trees here to arrest this sand movement, because sand used to get blown onto the site and onto the settlement because of the southwest monsoon winds. So this site was very complicated because it had archaeology, it had sand accumulation, it had vegetation. So sometimes if it had only vegetation, maybe multispectral data could have shown us some patterns, or if it had only sand, radar could have shown patterns, but they both together complicated it by negating each other. Because of the sand accumulation, the amount of feature you can see on multispectral data became little blurred, and vice versa. But still, we looked at the larger area and tried to identify some features. And we found a linear feature that connects the site with a nearby dam. Here is a dam, as you can see. The river is here, and the discharge below that is less. If you visit this location, you'll find there is a modern dam, but there are also remains of an old dam. And the old dam was built in the 14th century. So there is a linear feature marked here as L1 in pink that connects the dam to the settlement area. There is another linear feature like a ridge which encompasses, sort of surrounds all these remains. What I've marked as yellow dots are locations where excavations were done. And there is a patch of extra water, extra moisture, and extra vegetation. And there is a rectangular patch that is or aligned with this linear feature. So the first linear feature I interpreted as a canal that drew water from this dam. The second linear feature as an enclosure wall. The third, the patch, as an area where agriculture was practiced in historical times. And the fourth one, which is rectangular here, which is aligned with the canal, as a reservoir which collected water from the canal. These were my identifications, and a group from Mysore University and in collaboration with the Department of Archaeology, Karnataka, excavated one trench along this reservoir. And as you can see, to reach the soil, they had to remove sand for about 3 meters. And a trench of 22 meters long and 1 meter wide was selected. This is because we were able to identify this location only through GPS, and to consider the error for GPS, we took a long trench. And we did reach to the subsurface where there was a collapsed structure, and also analysis of this, which was published in 2019. My work was done around 2007-8 during the excavation, and analysis was finally published, and it proved that there were evidences in the trench of that being a wall of a bund. And this finally went into the excavation report as well. My last case study is Mahabalipuram. Mahabalipuram is a port site of Pallava dynasty, which was built in the 8th century, but it also acquired a name, exonym, that is a name that externally known as 7 pagodas. As the name suggests, it was a European name. The name was given to the site by European maritime travelers who were passing by this, saw 7 monuments standing on the coast, which rendered itself as a unique landmark for people who were traveling. And this particular name has caused quite a mystery, because today, if we sail across Mahabalipuram, we only see shore temple, we don't see 7. And so this has resulted in the belief that maybe the rest of the pagodas are underwater, because there are remains underwater. But finding of a Portolan chart, Dutch-made Portolan chart of 1670, part of which is here, which also marks specific shaped monuments, structures along a coastline that is very different from today. I was able to identify each of these monument one to one of each one of these icons marked on this map as these monuments, because you can see there is one which has a tall tower and a short tower, which is very much like the shore temple. There is another one which has a flat top, which is like very much like this Volakanatha temple. And similarly, looking at the shapes of these temples, I was able to identify all 7 of them. And I found that these 7 are actually standing further inland. So which shows the shoreline was further inland at the time survey for this map was done, which also shows why shoreline is actually standing, shore temple is actually standing in water. So this in turn helps us also understand, use this kind of analysis to contribute to geomorphology, of course, the geomorphology. This becomes an evidence that coastline has changed since the 17th century to now. My sixth chapter is titled Site Protection Boundaries, a Double-Edged Sword. So far, I have given examples of how remote sensing shows the features in the vicinity of site that were originally part of the site. Therefore, if I ask the question, can geospatial analysis be used for preserving, conserving, and managing cultural heritage sites? The answer would be confident yes. But let's see what happens in practice as of now. It is very important to define boundaries to implement protection, because if one did not have protection boundaries, this is what will happen. For instance, here is an unprotected site affected by widening of Airport Road in Bangalore. Here, an armory of Tipu Sultan's time had to be removed, spending crores to make way for doubling of railway. But see what having boundaries can do. Look at the amount of urbanization in the landscape of Bodh Gaya from around the time it attained World Heritage tag to now. One wonders, is the recognition really protecting the site? Therefore, site protection boundaries are a double-edged sword. If you don't identify boundaries properly and regulate the land use, then we lose them. We need to define boundaries for practical purposes of implementing protection measures, but an inadequately drawn boundaries can become the cause for the spatial context of the site or the archaeological landscape to be damaged. The site can become a victim of its own popularity. For instance, Nalanda was tagged as World Heritage by UNESCO in 2016 with a core and a buffer zone. But look at the expanse of its remains. One wonders, will the landscape see the same fate as Bodh Gaya in the next 2 decades? So, remote sensing data analysis enables visualization of some of the limitation of current approaches, and more widely adopting remote sensing in GIS in the practice implementation monitoring can address these limitations. Chapter 3, last chapter, I discuss opportunities beyond landscape. Remote sensing can help, for instance, even measuring angles of sacred sites, and maybe compare them with astronomical phenomenon, as I was able to do with Nalanda's sacred structures. Another field is military history, military maps. For instance, here of Srirangpatna, the episodes when Tipu's rockets were used. Using these maps and analyzing the landscape, I could actually identify where the rockets were launched from and where did they land, and therefore identify its measure its range, which is about 2.48 kilometers. And as already explained, this kind of study can contribute to coastal geomorphology. The three potential groups of users who can benefit from the kind of work I have presented today are: the first group comprises of students and budding or established researchers in the field of archaeology, history, and art history who see potential value in analyzing landscape in their region of interest. I'm sure several of you are from that group. The second group of users are authorities concerned with the protection of cultural heritage. They are part of international organizations such as UNESCO, as well as national and subnational agencies. In India, these agencies include Archaeological Survey of India and each state's Department of Archaeology. Their mandate includes defining property boundaries for protecting archaeological sites and regulating changes in land use in their vicinity. Finally, non-governmental bodies and private professionals who are involved in making maps and master plans for cultural heritage protection and conservation. Adopting remote sensing GIS would help users in this group develop more efficient and effective processes as they scramble to document and protect thousands of immovable cultural heritage artifacts before these are consumed by expanding cities, industries, transportation networks, and other hallmarks of rapid development. Here is a picture of my institute where I have been working, first of all, as a PhD student between 2005 and 10, and then from 2015 onwards as a faculty. Thank you very much for your patient listening. I look forward for your questions.